In the last video, we talked about different equations of a line: standard form, slope-intercept form, and point-slope form. Now we actually want to look at some different types of properties or problems for these lines and how we actually use those equations. So first off, we want to look at parallel lines. And we all know what parallel lines are. If I have two lines like this and this, those are parallel. As far as it goes though, we want to be able to find the definition. And there are different definitions we can use, kind of the two lines that don't intersect, two lines that are next to each other, two lines that when I graph them look like that. But for the purposes of this class and from a mathematical perspective, we need an algebraic definition that we can use. And if we look at it, well, if these lines are never going to touch, they have to go up at the exact same rate. And the rate at which they go up is their slope. So one way we can define parallel lines is two lines with the same slope. The problem is, from a math perspective, we have what's called necessary and sufficient conditions. That is necessary. If they don't have the same slope, then one of them will get bigger faster, and they'll eventually cross each other and won't be parallel. So they definitely need the same slope, but that's not sufficient. Because in theory, I could have one line, and then have another line directly on top of it. They would have the same slope, but they wouldn't be parallel because they'd be the same line. So in order to make the definition work, we say parallel lines are two lines with the same slope and different intercepts. Essentially, if we say they have different intercepts, we guarantee they have at least one point that's different, which means they're not the same line, and they have the same slope, so they're parallel. And again, there's different things we can do with this, but probably the easiest way to see what's going on is to actually look at a few problems. So, suppose we have something like this. Find the equation of a line that is parallel to 2x plus y equals 8 going through the point 1, 1. Find the equation of a line that is parallel to 2x plus y equals 8 going through 1, 1. One thing to note, for a lot of the applications we've done, you're generally solving an application to get a number. For this, you're told to find the equation of a line, which means your answer has to be the equation of a line. If it's not, if it's a number, if it's a point, if it's anything like that, it's wrong. We need to give an equation. But that actually makes it easier, because as soon as we're supposed to give an equation, and in this case, the equation of a line, I know I just have to use those equations of the lines that we went over in the last video. But then we have, let's see, we need an equation that's parallel to this line and goes through that point. Well, if I want a line parallel to this line, we said parallel lines have the same slope, which means the line I'm looking for has to have the same slope as this line. So find out the slope of that line. To find the slope, like we said last time, solve for y. If I solve for y, I get y equals negative 2x plus 8. And then, this is in slope-intercept form, n is equal to negative 2. So now, I need a line that's parallel to this line going through this point. To be parallel to that line, it has to have this slope, and it has to have that point. Well, now I have a point and a slope, which tells me immediately, for an equation, I can use my point-slope form. Y minus y1 equals m times x minus x1. My point will just be the point I want. Y minus 1 equals x minus 1 over here. Then I just need a slope, but to guarantee it's parallel to this one, I just use the same slope. -2. Now, is this line parallel to that line? Yes, they have the same slope. The definition requires they have different intercepts. You can actually check if you plug in 1, 1, it won't go through that point. More to the point, if these two lines don't end up with different intercepts, you can't solve the problem, which means the person who wrote the problem didn't know what they were doing. So trust me, they'll have different intercepts. But these lines have the same slope, so they'll be parallel. And this line goes through this point because I guaranteed it with the equation. So there we go. This is the equation of a line parallel to the first line going through that point. I am actually fine with you leaving your equation like this in point slope form. I wanted the equation of a line. That's the equation of a line. If you're so inclined, or if the book or your exam or whatever says to put the line in a certain form, like slope-intercept form, just do that. In this case, just a c slope-intercept, multiply the -2. Y minus 1 equals -2x plus 2. Add the 1. Y equals -2x, 2 plus 1 is 3. And there's my line in slope-intercept. Either one is fine, it doesn't matter, but just be aware, if the problem specifically asks for one or the other, make sure you put it in the correct form. Good. We're going to mess around with this a little bit more, using one other, we'll say, types of lines or properties of lines. Generally speaking, once you start talking about parallel lines, you also talk about perpendicular lines. So we will look at those. And again, much like with parallel lines, we all have an idea of what perpendicular lines are. If I draw that and that, are those perpendicular? Yes. Why? Generally speaking, if we look at it, we say, well, they look perpendicular, or we have right angles right here. So two lines are perpendicular if they meet at right angles, which is a geometric definition of them. Problem is, we're doing algebra here, so that geometric definition doesn't really help us. As far as the algebraic definition of perpendicular lines, two lines are perpendicular if they have negative reciprocal slopes. Before we actually use this, just to make sure we're clear, negative reciprocals, the idea is kind of break this up, start with negative. If I have the number 2, the negative of 2, you switch the sign, it's -2. The negative of a third is -1/3. The negative of -4, you switch the sign, is +4. When you talk about reciprocals, we know reciprocals means flipping. So if I have 2, the reciprocal of 2 is 1/2. If I have 1/3, the reciprocal of 1/3, you flip it, is 3. If you have 4, -4, the reciprocal of -4 is -1/4. So for negative reciprocal, we actually do both things. We flip the sign and we flip the fraction. So, if I have the number 2, the negative reciprocal, that's positive, so it's -1/2. If I have 1/3, negative reciprocal, so flip the sign, positive becomes negative, flip the fraction, 1/3 becomes 3. If I have -4, that's negative, flip the sign to positive, flip 4 to 1/4. And those are negative reciprocals. There's actually another kind of trick that happens here. If you multiply these together, 2 times -1/2, the 2's cancel, you're left with a negative, so it's -1. Here, if you multiply, the 3's cancel, you're left with a negative, it's -1. Here, if you multiply, the 4's cancel, you're left with a negative, it's -1. That will always happen when you multiply a number by its negative reciprocal. Everything cancels out except for a -1. Which means another way we define perpendicular lines is by saying, let's see, Two lines are perpendicular if they have negative reciprocal slopes, or the product of their slopes is -1. Now, we have an idea of the definition. We just want to solve a problem, but it'll be very similar to the problem we just solved. So, find the equation of a line that is perpendicular to 2x plus 3y equals 6, going through 1, 2. Very similar to the last problem we saw with parallel lines. Find the equation of a line that is perpendicular to 2x plus 3y equals 6, going through 1, 2. Much like the last problem, we understand I'm looking for the equation of a line, only this time I want a line that's perpendicular. How do we determine perpendicularity? By looking at the slope. So find the slope of this line, just like we did last time. How do we find the slope? Put it in slope-intercept. Solve for y. So I get 3y equals -2x plus 6. Divide the 3. Y equals -2/3 x plus 6/3 is 2. Now that this is in slope-intercept, that's the slope right there. Now I just have to keep in mind, I'm looking for a line perpendicular to this line. If I want it to be perpendicular, that means the slopes have to be negative reciprocals. So if this slope is -2/3, the negative reciprocal of that, flip the sign, negative becomes positive, flip the fraction, 2/3 becomes 3/2. That will be the slope I want, and I want it to go through this point, so I do the exact same thing. Point slope form. Y minus y1 equals m times x minus x1. So it's y minus 2 equals m times x minus x1. And there's my equation of a line in point slope form. Is it perpendicular to that line? Yep, we made sure the slopes were negative reciprocal, so it's perpendicular. Does it go through that point? Yep, we plugged that point in, so we're good to go. And one thing I would kind of note right at the end here, we did one of these problems with a parallel line, we did one with parallel lines, one with perpendicular lines. The method of solution algebraically is the exact same. Find the slope of the line you're given by putting it in slope-intercept. Then use point slope form with the points you're given and either the slope you started with, if you want a parallel line, or the negative reciprocal, if you want a perpendicular line. So just kind of understand the algebra of how we're solving these things out. The only real difference is, do I use this slope for parallel lines or that slope for perpendicular lines?